Let's talk about recursion terms. Recursive call. It's a method call in which the method being called is the same as the one making the call. So direct recursion is a method directly calling itself. One example is factorial. And the other one is called indirect recursion. So indirect recursion is really, instead of having just one factorial, you can have a factorial calling another helper method, and that helper method in terms calls factorials back. So it's almost like having another proxy right in the middle. F, calls another f prime. So f stands for function. F prime then calls back into f. This chain can go on and on. It doesn't have to be one proxy right in the middle. It could be two proxies. That's what indirect recursion is. The other one is called direct recursion. So let's talk about the recursive call. So let's just move on to this online IDE here. So what you see here is a public class. It has a public main right in the middle. Public main is the entry point for any console applications. If I were to create another static void test, so anything that has a static in front of it, let it be a static member, let it be a static functions, they are not part of a class. So when you have a static main and static test, they're basically sitting in a memory compartment that's in either stack or heap. A static can call static. If I were to do test, this test itself calls itself. There's going to be another call to itself, and maybe there's something else. Now, this is what we saw earlier, right? What is a recursive call? The recursive call is this calling itself. In the factorial problem where you have n times f, n minus 1, f is the factorial, n minus 1. So the recursive call is actually this portion. That's the recursive call. This example, the recursive call is the test itself calling it. Inside your main, you have another call out to test. This test is a little different than the test that you see in the recursive functions here. The test itself is not a normal method inside a class, this class main. This test is actually a function, normal function call. On the bottom, this one is called recursive call. Blue one is recursive call. Red one is the normal function call. And then we talked about direct recursion and indirect recursions. Sometimes you don't need to have recursion. Recursion is pretty expensive. Always remember that. In the factorial problem, we could have turned the entire problem into a for loop. For loop is a specialized version of while, so you can use while as well. Every time you use a while loop, it introduces a initialization expression. Integer is 8 bytes. The iterations doesn't really take a lot of space because it's in the same flow of control, and this flow of control does not call another function. Now, what gets really, really expensive in recursion is the fact that if you look at this entire stack, this is the stack that we just talked about. When you call functions, the function A calls function B, B then calls function C. So this is not recursion. The fact that every time you call a function, there is a function pointer associated with that function that you have to store in computing memory. Now that computer memory happens to be stack. This is stack memory. So A calls B calls C. It's actually going to introduce a whole bunch of function pointers pointing to each other. And these pointers are memory addresses. So you have to kind of store them last in, first out. So let's just stop. The very first one is here, and then you have B, and then you have C. A calls B and calls C. This stack is actually a lot more complicated. Every time you call a function, each parameter gets copied itself. So there's going to be more of those here. Just to illustrate, assuming the stack only shows the function pointer, A, B, and C. Recursion is going to call itself. That is going to call itself again. And that is going to call itself. So every time a function calls itself, presumably the problem space shrinks at each level. But then again, your stack memory is shrinking too, because stack is only so big. This is the reason why you don't want to have recursion that goes on to infinity. If you can, and this is my advice too, convert a recursive problem into an iterative problem, that would be a big win. This is an example of the factorial problems that we went through in iterations.